Running an optimization. 90. Start running an optimization. RISKOptimizer will take some seconds to define its starting settings. It will then start showing the RISKOptimizer progress window. 91. Click on the magnifying glass icon in the RISKOptimizer progress window. This will display the RISKOptimizer Watcher, a multi-tab dialog. RISKOptimizer Watcher is responsible for regulating and reporting all RISKOptimizer activity. From RISKOptimizer Watcher, you can change parameters and analyze the progress of the optimization. You can also see real-time information about the problem, and information on RISKOptimizer's progress in the status bar across the bottom of RISKOptimizer Watcher. The Progress tab shows how results are changing, by simulation, for the selected target cell. Progress graphs show the simulation count on the x-axis, and target cell value on the y-axis. The Summary tab displays a table of adjustable cell values tested during the optimization. If the genetic algorithm engine is in use, tools for adjusting the crossover and mutation rate for each adjustable cell group in the model are also displayed. The Log tab displays a summary table of each simulation run during the optimization. The log includes the results for the target cell, each adjustable cell, and all constraints. From the Show dropdown, you can request a log of all trials or only those simulations where there was a progress step, that is, where the target cell value improved. The log shows a row for each simulation, including elapsed time, the start time of the simulation; iterations, the number of iterations run; result, the value of the target cell's statistic being optimized, in this case, the mean of the end portfolio value; then the output mean, output standard deviation, output minimum, and output maximum of the target cell distribution. Input columns, the values in the adjustable cells; constraint columns, indicating whether the constraints are satisfied. This optimization is being run under an automatic optimization mode. We can intentionally choose, as mentioned before, to run it either under genetic algorithm, or opt-quest. The genetic algorithm method allows for more customization and, under certain circumstances, for better optimization results. One disadvantage, however, is that under genetic algorithms, multiple CPUs cannot be used for optimization, rendering a slower optimization process. 92. At this point, we will stop our optimization process after a flat line has been achieved for enough time on the progress window. Usually, the flat line is a good cue that the software has already achieved an optimization target. As opposed to linear deterministic programming, where achievement of a theoretical maximum or minimum can be mathematically achieved and proved, these numeric algorithms can never prove that optimization has been absolutely achieved. 93. Stop the optimization. We will skip the request for generating reports. Going back to the model, observe that cells on the range C2:F2 contain the optimized portfolio. This is the quantity of ounces that you should have in your portfolio in order to maximize the mean of the portfolio in 24 months. 94. Change the number of iterations back to 1000 and start running a simulation. After the simulation has been executed, place your cursor on cell G284, our output, and browse results. You should be seeing the following portfolio curve. This portfolio can be interpreted as follows. There is approximately a 40% probability that this portfolio will lose value after 24 months, a value of less than the original of $200,000. There is approximately a 28% probability that this portfolio will increase its value after 24 months by more than 50%, a value of more than $300,000. The shape of the curve is clearly asymmetric, generating potential results of over $1 million, although highly unlikely. Notice, for example, that the most likely value, the mode, stands at $174,000, substantially lower than the mean at $259,000. Observe that this portfolio is highly dependent on palladium, with 90% of its value coming from it, the riskiest of the four metal commodities. The other metals are there only because a minimum share was required. On column N, we will place a statistic function that calculates the objective to be optimized for each one of the portfolios to be compared eventually. 95. On cell N2, insert the following function, equals risk mean, G284, H2. This formula will calculate, after a simulation is run, the mean of whatever value we have placed on cell G284, in this case the final value of the portfolio. The second parameter, H2, which makes a reference to a number 1, is used to refer to the number of the respective simulation. At this point, since we are only running one simulation at a time, this second argument is purely optional. Later on, When we will run multiple simulations at a time, we will see why this optional parameter becomes relevant.